Today I want to talk to you about factoring completely. A lot of times we'll factor an expression and we get excited that we factored something out and we forget that we can go a little bit further. So I have a few examples to look at here on that topic. So first of all, when we're factoring, we should always look for the greatest common factor first. We'll refer to that as the GCF throughout the rest of this video. So looking at this problem, is there something that all three of those terms have in common? Well, yes there is, and let's look at the coefficients of each term first. 15, 30, and 40. What number divides evenly into all three of those? And that would be 5. So I will factor out 5. Now we've got to look at the variable parts. Are there some common factors among all the variables? So let's look at the m's. We have m cubed, m squared, and m to the 5th power. Well, what we can do is just look for the m with the lowest power, and that would be m squared, so that's all that these three terms have in common. Let's look at the r's. We have r to the 7th, r to the 1st, r cubed. r to the 1st being the lowest power, so that is all that we can factor out in terms of r's. Alright, so we know our GCF is 5m squared r. Now we need to look at what numbers we have to multiply by here to get our original expression. So 5 times what gives us 15? 3. M squared times what gives us m cubed? That would be m to the 1st, we'll just write m. And r times what would give us r to the 7th? That would be r to the 6th. Alright, moving on to the next term. 5 times what would give us negative 30? That's negative 6. And m squared times what gives us m squared? Well, that's just 1, so we don't need to add anything else there. R times what would give us r back? That's also just 1, so we don't need to add anything else to that term, so we're done with the middle term. Moving along. 5 times what gives us 40? That's 8. And m squared times what here would give us m to the 5th? That would be m cubed. And r times what would give us r cubed? That would be r squared. So we factored out a GCF. We need to take a look at what we've got and see if there's anything else that can be factored out, if there's another way to factor this trinomial any further, and in this case there's not. So let's look at a couple more examples. So in number 2, I see I have a trinomial here. The first thing I always need to look for is a greatest common factor. Is there a GCF in this case? And there is. What is it? It is 4. So we will factor out a 4. Quick check, we got x squared here, x here, but no x's here. So there's nothing else that all three of these terms have in common. So 4 is our GCF. And 4 times what gives us 4x squared? That would be x squared. 4 times what in this position would give us negative 28x, and that would be negative 7x. 4 times what in the last spot would give us 40 back, and that would be 10. Okay, so we factored out a GCF of 4. Now we've got a trinomial that we need to look and see if we can factor or not. It looks like we probably could, and I'm going to use the diamond method. You may have another method for factoring trinomials like this, that's fine. So I set up my diamond, and in the top of the diamond we put our product of A and C, which would be 10, and in the bottom we put our B value, which is negative 7. So we need to find a factor pair of positive 10 that adds up to negative 7, and in this case that would be negative 5 and negative 2. Negative 5 times negative 2 does give us positive 10, negative 5 plus negative 2 gives us negative 7. So we know our complete factorization would be 4 times x minus 5 times x minus 2. Make sure you slide that 4 down to your final step because 4 is one of the factors of this original expression. Nothing else we could factor any further, so we're done here. Alright, 2 more. On the third one here, I see, looks like we have a GCF of 3. That's good. So we factor out a 3. 3 times what gives us x squared? 3x squared, that would be x squared. 3 times what would give us negative 75? That would be negative 25. So we factored out a GCF of 3. But what we should see is that what we have left is a difference of two perfect squares. You may have different ways you go about factoring that. I kind of like for my students to just recognize quickly if they have a difference of two squares that it factors into two very similar factors, the only difference being the sign in between. So we get x plus 5 times x minus 5 for x squared minus 25. So we were able to take it a step further. We've got to bring that 3 down because it is part of the factorization of the original expression. All right. One more. Number 4. So looking at number 4, we have a trinomial here. I do see some things that they have in common. It looks like they're all even, so certainly they're all divisible by 2. I do notice that they all have an x in them as well. So the GCF on this problem is going to be 2 and x. All right, so we factored out 2x. 2x times what gives us 12x cubed? That will be 6x squared. 2x times what gives us negative 26x squared? That would be negative 13x. And then 2x times what gives us negative 10x? That would be 5x. Let's make that negative 5x. Change that real quick. All right, so we've got a trinomial left in, let's see, one more mistake. I need to erase that x, just minus 5. Okay, so we have a trinomial left. We need to take a look at factoring that, and we'll use the diamond method again. So on the top of our diamond, we put a times c, which is negative 30. In the bottom of the diamond, we put our b value, which is negative 13. So we need two factors of negative 30 that add up to negative 13, and that would be 15 and 2. We just need to give the negative to the right one. That will be negative 15. All right, now we need to divide each of those by the a value, which is 6 in this case. Looking at those two there, both of them can be simplified, so let's simplify those. It will be negative 5 over 2, and this would be 1 over 3. So from that, we can go to our two factors. We have 2x coming on down for the ride times, working from the bottom up, 2x minus 5, and 3x plus 1. So there is the complete factorization of the original expression. So make sure that sometimes when you factor out a GCF, there's more work that can be done. Just make sure that you factor things all the way every time. Thanks.